Hi everyone, welcome back. Today we are solving minimum operations to equalize binary string. So we will be given a binary string s and an integer k. So obviously it's a binary string. It will be consisted of ones and zeros, and our goal is to make the entire string consisted of all ones. And to do that, we can perform an operation in which we have the integer k, and we need to choose exactly k different indices and flip each 0 to 1 and each 1 to 0. And if we are not able to convert them to all ones, then we return -1. Otherwise, we'll return the number of operations it will take. So if we look at this example, k is equal to 1, flip this 0, so it takes one step. In this example, we will first flip these 3, so it can become 1000, and after that, we'll flip these 3 zeros, so now it's all ones, so it takes 2 operations. And in this example, no matter how many operations you take, you cannot get it to all ones, so we'll return -1. So now that we have seen some examples, let's get to how we can solve this problem. So there are a few things that we should know to solve this problem. So if we want to make a 1, if the number is originally 0, it will flip an odd number of times, whether it's once, 3 times, or 5 times. And if the original number is a 1, it will need to flip even number of times, whether it's 0 times, 2 times, 4 times, or 6 times, they will all end up being a 1. So therefore, knowing that, let's define I as the number of operations. If we perform an odd number of operations, then that means 0 can flip I times max because it's odd, and 1 will have to flip I minus 1 times max because I will be odd, so it will be I minus 1 times max. And for even, same thing. If it is even, then 1 can flip I times because it's even, and 0, since it has to be odd, it will be I minus 1 times max. So therefore, knowing that, let's say the number of flips will be the number of operations times k, and we also need to make sure that flips minus zeros need to be an even number for it to work. So let's say we have the string as 11000 and k is equal to 3. Now if it's one operation, then we get 3 flips. Now let's take the number of flips minus the number of zeros. 3 minus 3 is equal to 0, and 0 is even, so that's how we know that it works. And the flips also need to be greater than the number of zeros, because let's say we have 2 flips, but then our number is like more zeros than flips, then it will not be complete. Also, the flips need to be less than the max number of odd flips and the max number of even flips for the zeros and ones that we have looked at up here. And we also need to know that assuming that it's possible to make all strings equal to 1, it will take the length of the string times at most. So after we know all of that, we can now solve this problem. So what we can do is we can count the number of ones and zeros in the original string, and if there are no zeros, then we can return 0 operations because the string is already all ones. And now we can iterate from index 1 to the length of s, meaning 1 operation to length of s operation. So we know that based on this statement, and we will let flips be index times k. So index will represent the number of operations. Now if flips minus 0 is odd, we'll continue to the next one because we know that that number of operation wouldn't work based on what we said right here. It needs to be an even number. Now if it is even, we can proceed. So if index is odd, then we need to make sure flip is greater than or equal to the number of zeros and less than zeros times I plus ones times I minus 1 based on what we have defined here. If it is even, it will be also make sure that it's greater than or equal to zeros, and flips would be less than this equation, than this formula, which is zeros times I minus 1 plus ones times I, and it's based on what we have here as well. And if these conditions are satisfied and if this is satisfied, then we'll return index, or we can check this one. If it is satisfied, then we'll return index. And if we get to the end and we still have not returned index, then that means no number of operations can work, so we'll return -1. So let's go through this example real quick. So we have 2 zeros and 2 ones. Let's check if I is 1. We will get 3 flips because k is equal to 3. 3 times 1 is 3. 3 minus 2 is 1, which is odd. We know that cannot work, so let's check the next index. I is 2. 2 times 3 is 6, so we get 6 flips. 6 minus 2 zeros is 4. It's even, so we can check this condition. Flips is greater than 0, and is it less than or equal to zeros zeros, meaning 2 times 1 plus 2 times 2, which it is, because this would be 2 and this would be 4, and 6 is equal to 6, so we know that's true, so we can return 2 as our result. So the time complexity would be O of n, where n is the length of the string, because we will iterate from 1 to the length of the string, and the space complexity would be O of 1, because the size of these variables will not depend on the size of the input string. So now let's get to the coding part. So first, we will initialize zeros to the count of zeros and ones to the count of ones. Now, if zeros is equal to 0, then we can return 0. Otherwise, we will iterate from I to length of s plus 1. Flips will be I times k. If the flips minus zeros divided by 2 does not equal to 0, meaning if it is odd, then we will continue. Otherwise, if it is odd, then we want to check the flips is greater than or equal to 0, and flips is less than or equal to 0 times I plus ones times I minus 1. That's the case, we'll return I. Otherwise, we will assume that it is even. So we need to check flips is greater than or equal to zeros, and flips is less than or equal to 0 times I minus 1 plus ones times I. Because, just to remind, ones can be flipped even times and zeros can only be flipped odd times. So we return I if it's true, otherwise return -1 in the end. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.